Hello and welcome to Carlson Software. This short video will show you just one of the ways Carlson Software has been collaborating with ESRI to seamlessly integrate their GIS technology into the design environment with which you are already familiar, and how you can use it as an integral part of the design process. Esri ArcGIS servers are abundant and they are widely used by both public and private organizations worldwide. Among other things, contemporary ArcGIS servers have the capability to dynamically publish maps and other geospatial data online without the need for the creation and transport of intermediate files using different software packages. Carlson ArcGIS Map Services allows you to browse and query the content of maps published by any ArcGIS server and make requests for it to compose maps with content you specify. The results are georeferenced in any coordinate system you wish and delivered directly to your drawing. So let's have a look at how this works. To begin, we will just use a blank drawing and the command GIS data import ESRI map service image from the Carlson GIS module. An important concept with which most surveyors and engineers are keenly aware when using geospatial data from multiple sources is that they must all share a common spatial reference. With the aid of GPS and other positioning technologies, most engineering drawings today are georeferenced, but of course a blank drawing has none. The command recognizes this and requests that we either establish one now, or we could run drawing setup from the settings menu. Clicking OK will display a tab dialog with two spatial reference resources. This first one is the online resource found at spatialreference.org, and the other is a local database installed with the software, and it contains all the spatial references published by ESRI. This first example, we will use data published by ESRI in the vicinity of Bloomfield Hills, Michigan, which is located near the city of Detroit in the southeast corner of the state. In the United States, the state plane coordinate systems are commonly used, so we can key in the term Michigan as a search criteria on either tab. And if I do this on the online tab, we can see the various known projections for Michigan. Doing likewise on the local tab produces a similar set of results. Flipping back and selecting NAD 83 Michigan South projection in the units of US feet from the online tab provides us an overview of the projection itself together with a small geographic display of the projection's coverage, which we can pan and zoom around on. And we click OK to accept the projection as described in the status bar, and that allows the command to continue. Now, ArcGIS servers may be bookmarked like a browser, and by default the command will connect to and query the services available from whichever one you designate as home. If I click the bookmarks button, you can see that my home ArcGIS server is ArcGIS Online, and that I have also added a number of state and local hosts. For this first example, we'll be using both ArcGIS Online and the ESRI sample server, which hosts some large-scale data for Bloomfield Hills. And since I have no georeference survey data in this drawing, I first need to navigate to the geographic area of interest. An easy way to do this is to use the image place Google Earth image command. For convenience, I have Bloomfield Hills saved as a place, and which if I double click it'll navigate us to the area of interest. And on this screen the display I know is limited, but we don't need much to allow us to quickly position a drawing to this area in the Michigan South State Plane Coordinate System. Activating the Carlson window, we just click Current Google Earth View, and note in the status bar that we're currently viewing about third square mile area. Clicking OK prompts us for the file in which to store the image and places it in the drawing. Now I just zoom extents, and you can see the image and the status bar coordinate display looks reasonable for Michigan South, reference to NAD 83 coordinates in US survey feet. In general, we'll be focusing on this area right here around Juniper Lane. So now we can return to GIS data import ESRI map service image, and it will reload all the map services available from ArcGIS Online, which is my home bookmark. I'm going to select the USA Topo Maps first, and you'll note that the descriptive information supplied by the service provider, this one is pretty well detailed and indicates the source of the published spatial reference of these maps, which is not the Michigan coordinate system of our target drawing here. We can also see that there's only one layer in this service named USA Topo Maps, and that it is included by default. And we know that by virtue of the layer icon being highlighted in green. So we just click Enable, which activates a layer control, and into which I'm going to key in a new layer name. I'll call it USGS Topo. And click OK. That'll dismiss the dialog, and what it's going to do is solicit an area of interest, and we can define that using either a pair of points. We can select an existing polygon type entity or the current view, and I'm just going to identify the Google image that we placed previously to replace it with this topo map. And we'll now see a progress dialog in which we can see the source and target spatial references together with a log of the interaction with the ArcGIS host. Using the layer control for a moment displays the layer created for us, and freezing it shows that it is on the layer that we specified. So now we return to the Map Services command. We're going to reference the World Imagery Map Service in the same way, and from which we will request an area surrounding the area we're really interested in around Juniper Lane here. We enable that and enter a layer name of ESRI World Imagery something. Click OK, and then identify a window around that street that will request and insert the imagery into the drawing. Finally, let's add some parcel and building data from a different ArcGIS server. So we connect to it, and we can see a folder here for Bloomfield Hills. And opening that, we can see two map services. One's titled Land Use Planning and the other is Parcels. So we'll click on the latter one here, and it informs us of the content, and note that it's published in the same coordinate system set for our drawing. But the units here are international feet. That's okay. We also see that it contains 3 layers. They're all enabled by default, and there's one table as well. Let's just get the building footprints and parcels for Juniper Lane. So to do that, we just click on Building Footprints, and that also displays all the attribute fields associated with that layer. And clicking on that, we can see an attribute entitled Full Site Address here. So we'll select that, and we also select the operator like together with a value of Juniper, and we're going to surround that with the % character and add it as an AND clause to restrict the footprints that we request. And note that the operator equals would probably not select what we want, because the full site address likely contains street numbers and other things, and we include the wildcard % character before and after to indicate that we don't care what may come before or after that street name. Then we click Enable on that layer, and then we're going to do more or less the same with the tax parcels layer. Now, this list of attributes is more extensive, but site address here is likely the one that we're interested in to restrict the selection. So again, we're going to use the like operator together with the same value, and again we're going to click Add as AND. Since we do not wish the tax parcel neighborhood layer, we will change the layer display and request only the enabled layers. And now we'll just enter a layer name. I'll call it parcels. And I'm going to click OK. And this time I'll just window an area around Juniper Lane. And you're going to see from the results that it appears that the parcel at the lower left is on the neighboring cul-de-sac, which is Brisbane Court, and those at the start of Juniper Lane are on its feeder street, Echo Road. As a second example, let's have a look at how we can quickly generate a compiled utility base plan for a given locus. The city of Norfolk, Virginia publishes such data via ArcGIS. And as you can see in this drawing, I have again established a target spatial reference, which is the Virginia State Plane Coordinate System South Zone, reference to the North American datum 1983 in feet. And I inserted a quick snapshot of a monochrome Google Earth imagery for a bit of the downtown area. The rectangle identifies a fictitious locus of interest, and first we'll connect to ArcGIS Online to replace the Google monochrome image with its color imagery. And to do that, we simply run the command import ESRI map service image, connect to ArcGIS Online, and then select and enable the World Imagery Service, and we'll assign a layer called GIS World Imagery. Click OK and select the Google Earth image frame, and we can see those results. Now, if we connect to the City of Norfolk ArcGIS server, we can see that they also published 6 versions of orthophotos beginning in 1999 right through to 2011. So let's click the latest one available, which is Air Ortho 2011, and its service does not provide much additional information except that it's published in our target coordinate system, and it's also, you can see, contained in a single ArcGIS layer. But we can probably assume that the compilation scale for local map services is larger and will contain a higher degree of detail. So we enable this map service and enter a layer name here of, we'll call it GIS Norfolk 2011 Ortho. And we click OK, prompts us for the spatial extent of interest, and we'll zoom in here and expand a bit beyond our locus of interest just for context. Command makes the appropriate request and places the image for us on the layer we've specified. Now if we reconnect again to the city's ArcGIS server, I'm going to turn around and click on the Norfolk Base Map Service, and we see again there's relatively little in the way of descriptive information, but the layer names within the service give a pretty good indication of the content. So I'm going to enable it and enter a layer name of GIS Norfolk Base, and now select that locus rectangle to make the request. And this one requires, you can tell, additional calculation on the part of the server, but we'll place the map, and it looks like a resolution of about ½ foot per pixel. And from the results, you can see the map containing color-filled polygon layers obscures the imagery below it, but it does display basic cadastral data, and we zoom in, we can see many of them, such as the parcel lines, the names, the numbers, we have easement information, and basic dimensions together with street names. So finally, we'll capture the water and sewer infrastructure by reselecting the command one more time, and I'm going to reconnect and enable both the sewer viewer and water viewer services. For the sewer viewer service, we provide a layer called GIS Norfolk Sewer, and we can see there are quite a number of default layers embedded in both the infrastructure and annotation layers. Let's omit the default large annotation layer since it's probably for smaller scale maps. And to do that, we just enable the large annotation layer and select default and hide enabled in the layer display options. Now we flip over to the water viewer service and we can do pretty much the same. Provide a different layer name of GIS Norfolk Water. I'll have a peek at the default layers, and we enable the large annotation layer, so that we'll turn it off with default plus hide enabled layer display again. And click OK, and we'll just identify that image frame from the base map, and that will insert each of these, which and it completes. We can see they are point and linear data oriented maps which do not obscure what is behind them. And note that we can easily isolate the layers by using standard layer controls. So I can either display the sewer independent of the water, and we can also show the utilities directly on the orthophoto by freezing that base map layer. Thanks for watching this video, and be sure and check out the many other informative videos available.